At point x equal to 1, we have this function x cube minus 1 when 1 less than x less than infinity, or otherwise x minus 1. Then this function, whether it is continuous, it is differentiable, it is not continuous, etc. First of all, discontinuous and differentiable. This is theoretically not possible, right? The function has to be differentiable. First of all, it has to be continuous. Right, continuity is the first basic criteria. Continuous, the function has to be continuous. Then only we can even think about or talk about differentiability. If it is not even continuous, there is no question of differentiability. Right. So the C option is straight away out. Right. Now, and this one is obvious, right? If it is discontinuous, obviously it will not be differentiable. Right. Now let's get into this problem. And let's try to draw the graph of these two functions. Right? How does x minus 1 look like? X will look like this. X minus 1 will look something like this. X cube minus 1. How does it look? X cube will look something like this. X cube minus 1 is this shifted 1 units downward. 1 units downwards. Right? It will look something like this. Okay. So now let us draw both these graphs. They look like this. Right? This is x minus 1. This is x cube minus 1. X cube shifted 1 unit downwards, and x minus 1, x shifted 1 unit downwards. Obviously, between minus 1 and 1, x minus 1 is greater. After that, x cube minus 1 is greater. Right? We know this very basic structure, right? How x square versus x versus x cube. Right? Before 1. Between 0 and 1, x is highest, after that x square, after that x cube. After that, the order reverses. Right, after 1 and greater than 1, x cube is highest, then x square, then x. It's the same thing, right? So, if it is like this, y equal to x versus y equal to x cube, right? Between 0 and 1, y equal to x would be higher, after that x cube, right? Now same thing if both the graphs are shifted 1 unit downwards, right? Now what it is saying, before 1 it should be x cube minus 1. What does that mean? Before 1, the graph, we have to take this graph before 1, and after 1 we have to take this graph. After 1 we are taking this graph, and before 1 we are taking this graph. Clearly at 1 there is a corner, right? This graph is not smooth. So at 1 it is not differentiable. It is continuous, right? At 1 both are zeros. X minus 1 is also 0. X cube minus 1 is also 0. At 1 both are zeros, and before 1 anyway this function is continuous. After 1 anyway this straight line is also continuous. So the continuity at 1 is also maintained. But at the same time, this point there is a cusp kind of thing. There is a corner thing here. This graph is not smooth. So it is not differentiable. Continuous and not differentiable. This thing is wrong because at 1 we cannot differentiate. At the point x equal to 1, the slope is not clear, right? If you are moving from here, coming from the left, then it looks like this is the slope. It looks like something like this is the slope. But if you are coming from the right, it looks like this line is the slope, right? One side you are getting a slope like this, another side you are getting a slope like this. So slopes are not matching. So this function is not differentiable at x equal to 1. Yes, it is continuous. So this is the correct answer. Very, very basic problem. We just need to draw these two graphs carefully and then just check. Right, guys? Thank you.